All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, tonight was heavy on the note taking, so we're going to do some light reading and we're going to leave it at that. So let's pick up where we left off. So, in effect, what pooling will do, it will take the feature maps and reduce their dimensions so that we end up with smaller grids and fewer pixels. And this then is going to be easier for us to deal with. It means fewer inputs that we have to worry about. It's also going to mean that we are more resilient, more robust against potential movement from particular values just by one pixel, when ultimately we really don't care about those pixel differences that might arise in the original image. Now, after we've done this pooling step, now we have a whole bunch of values that we can then flatten out and put into more traditional neural networks. So we'll go ahead and flatten it out and end up with a traditional neural network that has one input from each of the values from each of the results and feature maps after we do the convolution and after we do the pooling step. Now, this is the general structure of a convolutional network. We begin with the image, apply convolution, apply pooling, flatten the results, and then put that into a more traditional neural network that might itself have hidden layers. We could have deep convolutional networks that have hidden layers in between the flattened layer and the eventual output to be able to calculate the various different features of those values. This can help us to be able to use convolution and pooling to use our knowledge about the structure of an image to be able to get the better result, to be able to train neural networks faster in order to better capture particular parts of the image. And there's no reason necessarily why we have to use the step once. In fact, in practice, we'll often use convolution and pooling multiple times and multiple different steps. We might we might imagine doing what we might imagine doing is starting with an image, first applying convolution to get a whole bunch of maps, then applying pooling, then applying convolution again. Because the maps are still pretty big, we can apply convolution to try and extract relevant features out of the first result, then take those results, apply pooling in order to reduce those dimensions, and then take that and feed it into a neural network that maybe has fewer inputs. So if that example, we would have two different convolution and pooling steps. We do convolution and pooling once, and then we do convolution and pooling a second time. Each time extracting useful features from the layer before it, each time using pooling to reduce the dimensions of what we're ultimately looking at. And the goal now of this sort of model is that in each of these steps, we can begin to learn different types of features of the original input. That maybe in the first step, we learn very low features or very low level features. Just learn and look for features like edges and curves and shapes because based on pixels and the neighboring values, we can figure out what are the edges, what are the curves, and what are the various different shapes that might be present there. But then once we have a mapping that represents where the edges and curves and shapes happen to be, we can imagine applying the same sort of process again to begin to look for higher level features like objects or maybe people with eyes and facial recognition, for example. Or maybe look for more complex shapes like curves or particular number that we are trying to recognize, a digit in a handwritten recognition sort of scenario. And then after all that, now that we have these results that represent these higher level functions, we can pass them into a neural network, which is really just a deep neural network where we might imagine making a binary classification or classifying into multiple categories or performing various different tasks with this sort of model. Now we're gonna leave it there for the night. Like I said, it was just a lot of note taking, and so yeah, we did get to the point where we're going to start taking code. I didn't want to start taking code because we did take a lot of notes, so I didn't want to get myself jumbled up with taking a bunch of notes and then trying to write code on top of that. So we will pick it up tomorrow with the code that we're going to write, and it's going to be for a handwriting recognition program. So yeah, we'll dive into that tomorrow. So we'll have something interesting to go over. But of course, I will keep you guys posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.